Cool. Can everyone hear me okay? Okay, awesome. So hi, I'm Keith, and the presentation I have for you today is about decoupling your API backend, also known as how I learned to separate product concerns. It was a difficult thing to learn. So to start off with a little bit about me, my name is Keith Horwood. I'm the lead author of Nodejs. I don't know if any of you, or all of you have heard of it, but it's a Node.js framework for building decoupled API services, which hence leads into this talk really well. Previously, I was the engineering lead at a startup called Storefront, and currently I'm the founder and CEO of a startup called Polybit Incorporated. So to get started, I want to go over like a little bit of like the history of kind of web development and kind of what we've been doing for the past decade or so. So I think all of us have like a little bit or a lot of experience dealing with like web monoliths. So typically, we have this traditional like client-server architecture where your web browser is considered the client, and that's going to display your UI, your HTML, your CSS. It's going to run your JavaScript, and it's just doing back and forth stateless communication with your monolithic application server, which is typically built in like Rails, Django, Laravel, or if you go far enough back, and some of you are probably still using the stack like the LAMP stack. This is really cool, and like it worked really well for a really long time, but there are a couple of problems with it. First of all of your project maintenance when you're running applications this way is all in one spot, which is a good thing and a bad thing. The good thing is that you can just open up one project and have everything available there. So you can see all your JavaScript, all your, well, if it's Rails, you can see all your Ruby code. If it's Nodes, obviously your Node backend. But a bad thing about that is that you have like really tight coupling of all your concerns. I'm sure a lot of us have been burned before when we've started a new company or joined on a project where all of a sudden you have like Rails templating logic that's producing HTML, which is like wrapping JavaScript, which is producing like JavaScript templates, and it can just get like really confusing really quickly if you have like a poorly engineered piece of code. Also, this isn't typically easy to scale. There's been like a lot of infrastructure leaps and bounds in the past couple of years even that have had to do with switching from traditional like one server, one application to obviously VMs, to containerization, and containers are like the new thing that everyone's super excited about. So that's cool, but you still have scaling issues there. Node solves some of these issues in that Node actually vertically scales really well just because of like the event-based asynchronous I/O model, but you still have some issues with that. And then, so let's talk about like Node.js monoliths and kind of what we've looked at over the past couple of years. We had this idea that came back that everyone got really excited about, which was universal JavaScript. So to go back to the last slide, all your maintenance in one spot and like not proper separation of concerns, people started realizing like now that we have Node that's running on V8, we can just write JavaScript everywhere, which is awesome because it eases like cognitive overhead. You just don't have to make as many decisions. You're like, okay, I can think only in JavaScript. So people were really excited about that and said, yay, and we had a bunch of frameworks pop up out of that, some companies that got multiple millions of dollars in funding, but we still end up with a lot of problems in that a lot of your code is still really tightly coupled, like your front and your back end code. In fact, maybe even more so, because what a lot of these frameworks started trying to do is when people are given these opportunities, I think it's awesome about the web development community, but people try and be clever, right? They try and figure out like, okay, actually maybe there's like a new paradigm for like writing code here, in that we can write code in one spot and it's simultaneously operating on the client and the server. What does this look like? I think after experimenting with that for a little while, we found out that that was actually a little bit scarier than we thought it would be, and ends up making applications and programs that are actually very difficult to reason about because there's too much magic going on in the back end, especially for things like error tracing. And then when you have new developers jumping onto projects, it can get very confusing. Then we also had this thing, well, WebSockets really started becoming big when Socket.io said, hey, we can take care of everything like real-time related for you. So everyone started saying, okay, we have this new technology for the web. How can we leverage this to our advantage? And the very first idea was essentially, can we just do CRUD, like all of our create, read, update, destroy on WebSockets? And everyone's, oh yeah, that seems like a pretty cool use. Like it can update in real time. This is going to be awesome. But what it turned out is this is actually like a really low priority product concern. It's really cool tech that things can update live, but if you think of the types of applications that actually need like low latency stateful communication, you're looking at things like real-time chat, yes, although you can hack that with typical stateless REST, and like maybe online games and like multiplayer games doing that, you need really low latency stateful communication. But in terms of building products, you introduce like a lot of complexity to your application in the way that you're communicating with your servers, communicating with your clients, for like a very low return on investment in terms of the engineering overhead. So this is stateful and it's difficult to scale for different reasons than the traditional monolithic application. It's difficult to scale because the second you go to like more than one VM instance or container, all of a sudden those containers need to be aware of each other and need to be able to communicate to make sure all of your socket connections can communicate. So this brings us to the decoupled API. Now, really, what is the decoupled API? Well, it's stateless. So going back to like our original like monolithic architecture, we're just dealing with like typical RESTful requests. One request, one response. This is like super predictable, right? You don't have to worry about weird logic or getting requests at weird times to your clients. You just know that when you send it's like how a function operates, right? You give some data, you get a little bit of data in return. There have been some hacks around this, like long polling, that should probably just be left aside. But stateless communication, RESTful architecture works really well, and it's been around for a really long time, and we can trust it, and we know we can work well with it. The decoupled API has a solitary concern, and that's business logic. So your decoupled API service is not going to be serving like any static assets, no CSS, no HTML, no JavaScript. It's literally only concerned with like a standardized API output format, which if you talked to me a few years ago, I might have said like XML or something, but nowadays we've all kind of congregated around JSON for really good reasons. So your decoupled API acts as a database gatekeeper and a service dispatcher. So what that means is that all communication with like your core database, your core data layer, or if you have multiple data layers, all of your data layers should go through your API. Your API is essentially going to be the client-facing portion of your application. And in fact, you can actually just call it a service dispatcher because a database is effectively just a service that you're offloading state information to, right? So that's what your API layer is going to act as. And it's also going to do this cool thing, and it's going to treat the browser as a platform instead of a specific client target. So when you have a server, like a traditional monolithic application server, sending all of this HTML and CSS and JavaScript to the browser, you're treating your browser, you're essentially locking in your browser as like your only potential clients. And there are some concerns with like that, it's really tight coupling between your client and your server. And I'll get into the browser as a platform in a second. When we look at this awesome, huge flowchart. So I want to break this down really quickly. Blue are client layers, red is your API layer, and green is just offloading to third-party services. They could be internal services as well. So the way that what the decoupled API layer looks like is there's an insight into the way, when I talk about treating the browser as a platform, there's a specific insight into the way that we're actually using browsers nowadays, in that your browser actually isn't your target clients for the majority of cases. You can actually view the browser as a distribution platform for single-page applications and treat single-page applications as the client, whereby you're actually creating your own client, your own application client in Angular, or like in React for the UI layer, or you're using something like Vue. And so when you see it through this context, you actually separate that old monolithic web app into actually its own separate client for your API server. So the way that I suggest dealing with these this decoupled API layer is you still need to, there's still a couple of business concerns that are really important to tackle that you need like static assets for. You need compiled templates that are rendered on your server. And that mostly has to do with like SEO and branding. Google is still searching through text content to find out what's relevant about your application. There's actually been like a huge amount of engineering done to parse JavaScript and all this stuff, but really you're going to perform best in the context of delivering like a search engine optimized site if you can just put out traditional HTML. So what I'm putting forth here is that traditional web server, the Django, the Rails, the Laravel, that's serving your static assets should actually be considered a separate client. And it should communicate with your API layer through the back end. And like I said, the API layer should be your sole gatekeeper for your data layer. So when you need to make a request and say like, oh, we need all of these, we run a listing service, and we want to show all of these properties and have it indexed by Google because we need people to be able to search for this. In that case, that logic that's generating those templates for those pages should be on your discovery and branding server. It should actually query your API layer, not connect to the database explicitly. And one of the reasons for that is just like reducing code duplication.
You notably left out Express and Node from that category. Why is that?
Sorry, the API layer category?
No, from discovery and branding category.
Oh no, it's just for space. Like there's tons of options here. Yeah. So everything I've included here.
So it wasn't on purpose.
No, it wasn't on purpose. It's just literally just for space. Just wanted a couple examples. So along with these clients, we also see that like the number of clients that are actually interfacing with our APIs are growing exponentially. A couple of years ago, you could have had a talk where people are saying like, okay, it's the web browser as a client, and like mobile apps are the new client. There's going to be a ton of mobile apps. Oh my gosh, this is amazing. Like I said, a lot of companies were founded on this as well. Now we have even more clients, right? We're seeing with how cheap like hardware is nowadays, and the power that like very small pieces of hardware have to actually make like HTTP requests. We're seeing an explosion in like small, cheap IoT devices that need to connect to our APIs. We're seeing over the last few months, there's been this buzz around like bots. So these conversational interfaces that need to chat with our APIs. So this API layer just makes sense because you're often going to get like a project and say like, okay, we want a web layer to start off with, but how are these requirements going to change? Am I going to need to prepare for like some sort of other client interface? So that's the basic like schemata, I guess, and setup of like a decoupled API service. So what are the benefits of having this decoupled API service? Like I said, the number of clients that we have to deal with when thinking about and building web apps is increasing dramatically. We don't want to lock ourselves into having a specific client. With a decoupled API layer, you have one central source of truth. Like your API layer is essentially it's like your external facing service. You'll hear people talk about service-oriented architecture, microservices, all this stuff. Your API layer is essentially a gateway to the rest of your services. Whether they're third party or you build them yourself or whatever. And there's also a separation of concerns, not only in terms of like the code you write. Yes, all server-side code interfacing with my database goes on my API layer, but also in terms of like business concerns. When you think about what's important for a business as you're like working on a project or building a business, yeah, we need to like rank highly in Google. Like what do we do to change that? Oh, there's a certain team, maybe we can give like repository access to our marketing team because we know they know HTML and CSS. They can jump on this SEO and branding aspect and not even worry about messing with the API whatsoever. What are the drawbacks? So there are drawbacks. And they're actually pretty big, especially for hobbyist developers and people running solo projects, is that there's a different architecture essentially for every project or every part of your stack, right? You have a certain architecture for your API layer, you're gonna have a certain architecture for like your branding layer, for all of your client layers. So this raises problems with like infrastructure management and deployment pipelines. In that now you have all this additional added overhead cost of like, how am I actually going to get this live? Do I set up a Docker container that scales this, that like everything's still like coupled within this Docker container? Do I deploy them on separate services? What's best for this? What's the least expensive, etc. How do I scale this past 1,000 users? So what are the next steps here? Like I said, I'm the lead author of a Nodejs framework for creating API services called Nodejs. I mean, it's a vanity metric. We're at 2,900 stars, which is actually pretty exciting. We just launched in early January to a pretty cool response in Hacker News. And what Nodejs allows you to do is to build and deploy API servers pretty much effortlessly. The vision being, so this is my thank you slide, but the vision being that I think the future of dealing with cloud infrastructure and this architecture is actually being able to abstract it away completely. If we can provide the right tools to developers and we know the types of projects they're building because we know the types of services that they're focusing on building for their new projects or their businesses or their personal projects, we can actually do something like compile to the cloud. If you own the framework and know how people are building, you can optimize that deployment pipeline. So that's what I'm working on with Polybit. And if any of you guys have questions about that or what I'm doing in that space, feel free to email me. I think that's actually the most important part about this slide. I'm available anytime, keith@polybit.com. You can follow me on Twitter at KeithWHOR. The company's Twitter page is at Polybit. And yeah, thanks for having me, and I really enjoyed speaking.